Okay, review sheet number 11. Oops, I gotta pick new markers. Okay, review sheet number 11. So the question says, what dimensions will give a box with the square end the largest possible volume? So we're maximizing volume here. So that's what we're going to take the derivative of. So I'm going to go ahead and write the formula for volume. So once again, they have told us specific information about it. They said it has a square end. The box has a square end. So like we did all those problems in class, that means we have x times x for 2 of our dimensions. We don't know how long that box is. So, okay, that is not quality draw. It's not quality. Okay. So we don't know how long it is, so we're going to call that y. But the formula for my volume is x times x, which is x squared, times y. Okay? That's what I need to take the derivative of. But again, I have this problem because I have this goofy y. So I'm going to use the rest of the information to figure out what y is. All right, so what's the rest of information? Well, it says the sum of its length and girth. And even if you didn't know what girth is, it tells you that that's a distance around, but it also shows you in the picture. The length and girth, so that means plus, does not exceed 120. So you just use 120 for the maximum. We want to be able to use as much as possible because we want to maximize here. So the length, so let's see, length plus girth. Length and girth, we know that that's 120. And what does it equal? Well, the length is y. And the distance around a square, there's 4 sides, right? So if I go around that square, it's x plus another x plus another x plus another x. The girth, the distance around, is just adding those 4 sides together. So that's just x plus another x plus another x plus another x. That's 4x. So you have this equation, 120 equals y plus 4x, which is what it said. It said length and the distance around, and it's a square, so it's 4 times x. Thank you, Kitty. That's very helpful. So set y by itself. 120 minus 4x equals y. Okay, so now you have y isolated. So now you already know what to do. You're going to plug that into your volume formula. Okay, so the volume is x squared times 120 minus 4x. And I'm going to distribute. So I have 120x squared minus 4x cubed. And that's what I have to maximize, which means take the derivative and set it equal to 0. So derivative 240x minus 12x squared, set that equal to 0 and solve it. There's 2 ways you can do it. You can either factor out what's in common or, hey, 240x, I'm going to move the 12x over, the 12x squared over. I'm going to divide by 12 here. So I've got 20x equals x squared. Get rid of this x. An x canceled here, and I have that x equals 20. Okay, so let's see, what are they asking for? What dimensions will give the box the largest possible volume? So I know that x is 20. So if I make this box 20 by 20 by, now I just need to know what that size is. So go down here to your little definition statement. So 120 minus 80 tells me that the length would need to be 40. So 20 by 20 by 40 will maximize that volume.